If you want to know the real story about why your kitchen appliances fail after 5 years, do not listen to what the marketing department tells you at the showroom. Talk to the service technician who shows up at your door with a toolbox. Talk to the people who spend 40 hours every week inside the homes of frustrated consumers, replacing broken parts and uncovering manufacturer secrets. These professionals witness the deliberate design flaws. They see the components that could last decades but were engineered to deteriorate. They see the profit mechanisms that corporate R&D departments invested millions developing to ensure you never truly own what you purchase. And if you ask any seasoned service technician what appliances they personally chose to install in their own kitchen, you will discover something striking. Their homes are filled with older, simpler, unremarkable machines. No flashy displays. No internet connectivity, no app-based controls. They use basic, straightforward equipment because technicians maintain a detailed knowledge base. They understand exactly which product lines and which specific features guarantee financial extraction from consumers over time. Today, I am revealing that knowledge base. I will show you the 4 most destructive engineering schemes hidden in modern kitchens, the brands responsible for these schemes, and the unglamorous machines that actually function reliably. First on the list, the LG Smart Refrigerator with Wi-Fi communication. Step into any major appliance retailer, and prominently displayed is typically a gleaming $3,500 LG refrigerator model. It features a large touchscreen interface on the exterior. It permits remote temperature adjustments through a smartphone application. It sends notifications when door sensors detect openings. To someone who repairs these machines professionally, this unit represents a comprehensive failure of engineering priorities. The central deception involves a fundamental misalignment between thermal physics and design aesthetics, specifically the location of the ice production system. Producing frozen water demands temperatures below 32 degrees. Storing fresh produce requires temperatures closer to 40 degrees. To bridge this contradiction, LG engineers positioned the ice maker inside a confined plastic chamber positioned within the main refrigeration space, attempting to channel ultra-cold air. This creates an impossible situation. The plastic housing lacks sufficient thermal insulation. Every instance the door opens introduces ambient room air containing moisture. This moisture contacts the sub-zero ice maker surfaces. Condensation accumulates. The water freezes. The mechanism gradually transforms into a solid ice blockage. The plastic components surrounding the ice maker experience intense stress. They fracture and separate. Manufacturers have faced substantial litigation regarding this specific failure. Multiple consumer protection organizations have documented widespread complaints. Experienced technicians will advise straightforwardly: avoid refrigerators with ice makers positioned inside the main cooling compartment. Purchase a basic model where ice production occurs in the freezer section where it belongs. Second, the Samsung front-load washing machine with aluminum support structures. Professional laundries and commercial operations rely upon front-loading washers. They dominate the residential appliance market as well. Samsung aggressively markets these machines as premium, efficient products. However, concealed behind the stainless exterior sits a catastrophic materials science failure. The structural component supporting the rotating drum is called a suspension bearing assembly. In commercial-grade washers, this assembly utilizes solid steel or durable cast iron. These materials withstand years of repetitive stress. In Samsung and LG residential models, designers substituted these materials with a lightweight aluminum casting. Aluminum possesses advantages for manufacturing. The disadvantage is chemical vulnerability. This aluminum bracket sits immersed in a caustic environment. Washing machine water contains extremely concentrated detergent chemicals. Over extended periods, a process called electrochemical degradation begins. The aluminum undergoes molecular change. Its structure becomes porous and weak. The material deteriorates internally while appearing normal externally. Eventually, during a heavy wash cycle, the corroded bracket fails catastrophically. The entire drum assembly drops. It ruptures the surrounding plastic housing. The machine becomes permanently damaged. Repair costs exceed $700 for a replacement assembly. This exceeds half the machine's original purchase price. Technicians understand this vulnerability. They purchase vintage equipment manufactured by Whirlpool or machines designed for commercial laundromats. These machines use robust steel components designed to withstand chemical exposure. They sacrifice modern styling for fundamental durability. Third, the Bosch Smart Oven with electronic temperature control. Cooking appliances have historically been among the most durable items in any home. A gas stove from 1985 might still function perfectly. It is simply a metal box containing heat sources. Maintenance demands are minimal. Modern manufacturers, including Bosch and Miele, have transformed this simple, reliable device into computerized equipment. The engineering failure here concerns placement decisions. Modern ovens require digital controls. Manufacturers position these circuit boards directly behind the exterior. The oven cavity reaches temperatures exceeding 500 degrees. This intense heat rises and concentrates at the appliance's upper regions. The circuit boards sit directly in this thermal exhaust path. The constant temperature cycling damages electronic components. Capacitors dry out. Solder connections weaken. The control system eventually displays error codes and stops functioning. The oven becomes unusable. Replacing the control board costs approximately $400 and requires waiting for factory shipments. You cannot cook for 6 weeks. Your family depends on restaurants or takeout. Technicians reject these machines entirely. They select basic electric or gas stoves with mechanical dials and no electronic components. These devices require nearly nothing to maintain. A mechanical dial lasts indefinitely. Fourth, the premium quiet dishwasher with plastic wash mechanisms. Dishwashers from 2 decades ago generated significant noise. They contained metal grinding mechanisms. These mechanisms pulverized food particles. The machines were loud but functionally reliable. Contemporary manufacturers, including Whirlpool and Maytag, removed these metal components. They installed fragile plastic wheels and wheels. Manufacturers justified this decision by claiming consumers demanded quieter kitchens. The actual motivation is different. Plastic components cost less to manufacture. Companies prioritized cost reduction over durability. The consequence is complete mechanical fragility. If a small bone fragment, a shell piece, or a bit of broken glass reaches the plastic impeller mechanism, the component shatters instantly. The dishwasher stops draining. Stagnant water accumulates inside. Bacterial growth creates odor. The repair bill for a replacement motor assembly surpasses the cost of a basic dishwasher. Technicians avoid these machines. They maintain older Whirlpool and Maytag dishwashers that contain traditional metal grinding mechanisms. Older machines survive indefinitely. Observe what connects these 4 failures together. Manufacturers systematically sacrificed durability for reduced production costs and visual appeal. They replaced robust materials with cheaper alternatives. They positioned fragile electronic components in hostile thermal environments. They automated functions that never needed automation. They prioritized quarterly financial results over product longevity. The entire appliance industry has become an exercise in planned deterioration, disguised as innovation. The machines fail predictably after warranty expiration. Repairs exceed replacement costs. Manufacturers profit from the cycle. If you want to resist this system, you must completely reverse your purchasing approach. Eliminate machines with Wi-Fi features from consideration. Refuse refrigerators containing ice makers anywhere except the freezer. Avoid ranges with electronic touchscreen controls. Ignore dishwashers marketed as whisper quiet. Search for the most basic, plainest, aesthetically unremarkable appliance available. Select machines with mechanical knobs and switchers. Choose models that appear outdated and unfashionable. These homely machines represent actual ownership. You gain mechanical permanence. You escape the financial extraction cycle built into modern appliance design. You retain thousands of dollars that manufacturers intended to extract from you. If you watched this entire explanation, please subscribe. Every week, I reveal the engineered failures hiding inside the products you own.